Remember from the last module that I indicated that global variables are not really the best way to proceed when using functions. This module we learn a better solution. That solution is called function parameters. So let's first define what a function parameter actually is. A function parameter is a value that can be passed into a function to modify the behavior of that function. Do we know of any examples of this so far? Well, think about printf. We've called printf several times in the past. Sometimes we've called printf and say, can you please print out the value of this integer? And sometimes we call printf and we say, can you please display the contents of this string? And the results that we see on the screen, in other words, what printf actually does, depends on what we pass it. If we pass it an integer, we get a number. If we pass it a string, then we get the text in that string. In other words, we are passing some value in to the function called printf that modifies the behavior of printf. Printf actually does different things depending on what we give it. Now, admittedly, all those things are quite similar, but they're actually a little bit different. A very simple example of a function that we may want to create might be a function that simply adds two numbers together. It might add number x and number y and do something with the total. Perhaps it would print out the total. Now, the total that it printed would depend on the two numbers that got passed in. If I passed in 100 and 200, I would get a completely different result to if I passed in 1 and 2. So let's learn more about that. A function parameter can be thought of as a local variable that has been passed in from the calling function. A local variable, you might recall, is a variable that is only available inside the curly brackets of any given function. In other words, no other function has access to that particular variable. So what I'm saying here is that function parameters are also local variables. They're also only accessible inside a given function. Once a value has been passed in to a function using a function parameter, then that value is then only accessible from inside the function where it was received. No other function can access that particular parameter. Now, we've used several functions so far, like printf and scanf and fgetS and so forth. We've used such functions that involve parameters, but we've never actually created a function that involves parameters. We have in fact created a function or two, including main, but none of them have involved parameters. So we're going to learn now how to add parameters to the functions that we have created. This is what it would look like. Now, remember old strlen. Strlen is called like this. We create ourselves a string of any particular length, and then we pass that string, called name, say, into the function called strlen, and strlen gives us back a particular number which represents the length of that string. Now, obviously, somewhere in between those two lines we actually have to assign some value into name. We have to initialize name. But assuming we've done that, then the strlen would work, and if we passed in a short string we would get a small integer back for length, and if we passed in a great big name string we would get a large number back in length. Again, strlen, the value that strlen gives us back, or in other words the behavior of strlen, does indeed depend on the parameter that we pass it. So what does strlen look like if you were to write it as a function? Well, it would look like the following. You would have the name strlen, then you would have some round brackets. Now notice those are exactly the same round brackets as we use when we create a function called main, except this time we've got something in the round bracket. I'll talk more about that in a second because that is the actual function parameter. And then after that it's just the function as per normal. The statements that you can see there would of course be the processing that the function actually does. The guts of the statement of the function, if you like. So anyway, back to the inside the parentheses, inside the round brackets there, you can see char space str and then square brackets. That looks suspiciously like a variable declaration. In fact, it is a variable declaration. We are creating a new variable there called str. It is a local variable that can only be used inside this function. But here's the clever part. When strlen runs, the str local variable that you can see inside the parentheses there is automatically initialized to contain whatever was contained inside name. Now name you get from above, where we're actually calling strlen, we're passing it the value of name. That name and the str become copies of each other. The value in name is copied into the value in str as soon as the function is called. So if you like, a function parameter is a local variable that gets initialized to some value outside the function automatically. In this case, str is a function parameter that gets initialized to the value name, and name comes from outside the function, and that happens automatically every time you call strlen. So let's now go and have a look at an example very similar to this. This is strlen.c. In here I've written myself a function called strlength. I've called it strlength and not strlen because I actually don't want to get confused between this function and the standard C library function called strlen, so I've changed the name slightly. Now this strlength does not use function parameters. In fact, it uses a global variable. In fact, it uses two global variables. It uses one to determine the string that it's actually going to be measuring, and it uses a second variable called length to determine the actual length of the string. It fills in the length of the string, which is then used by main. Let's see how it works. We'll just compile it, run it. Please enter your first name, Mark, and the length of Mark is 4, as expected. So the program works, but what I'd like to do now is actually rewrite the program so that it does not use global variables, does not use either of these two global variables. That's going to be tricky to do because we still need to learn about function return values, and that's not till the next module, but we can actually get rid of one of these global variables, and one is better than none, so let's try and do that. I'm going to make this variable here, the string variable, not a global. I'm going to make it a local variable down inside the main program, so I'm going to put it in here. So now it is not a global variable, as you can see, which is a good step in the right direction. However, the program will now not compile because up here strlength does not know anything about this particular variable here, because string is now local to main, and so strlength, the function, does not have access to it. Our solution, of course, is to use a function parameter. I'm going to string into strlength as a parameter. So I've now declared that strlength will be using this one parameter. So you can think of the main function passing, if you like, a ball to the function called strlength. Now strl such a way that it will actually receive that ball, receive that parameter. So I'm now going to create a little parameter definition here, which will be char str bracket bracket. Notice that I do not have to call it string. Just because this is called string does not mean that this has to be called string. In fact, I can call this anything I like. So I will call it str. Now this then is the name of the variable that I'm going to be counting, so this has to be renamed to be str because it will be referring to this parameter right here. So what happens when this program runs is that this line will appear, which will cause this particular variable, or the contents of this variable, to be passed into the contents of this variable. In other words, the value of string will be copied into the value in str. And then the strlength function will run, and str will actually be measured in the for loop, as you can see, and the length variable will be set accordingly. Don't forget, length is still a global variable. It would be nice to get rid of that, but we can't do that just yet. Let's see if that runs. Compile. No errors. And run. Please enter your first name. And the length of Mark is 4. So it is actually working as before. We have not changed the functionality of the program, but we've changed the design of the program such that it uses less global variables now, which is definitely a good thing. This is average2.c, which is sort of like our last average.c, except that I've gone back to no longer using any functions at all. I am actually going to put one or two of the functions back again, but I want to do that in a very controlled way. So let's look at the design of my main now. I've got basically three different areas of processing as before. We've got the reading in phase, we've got the calculation phase, and we've got the printing out phase. Now what I'd like to do in this exercise is just remove the calculation phase and put it in a separate function. Now this is still going to require us to have a global variable, just like in the string example that we just saw. We will need a global variable to store the answer. In fact, we'll need a global variable to store, in this case, the average. But in the next module, when we learn about return values of functions, we'll be able to get rid of global variables altogether. So let's do a little bit of manipulation here. I'm going to make this average into a global, so that means it goes up here. And then I'm going to take this line of coding here, and I'm going to turn that into its own function. Now I'm going to put a function name around that, and the name that I'm going to call it is average, like that. And like so. This is pretty much as you've seen before. What I'm not going to do is I'm not going to take those three local variables there and turn them into global variables. I'm going to leave them where they are and pass them into average. So right here, in place of the calculation line, I'm simply going to call average, like that. Now as that stands, that will not compile, because up here in average it doesn't know anything about anything called num1, num2 or num3, and the reason it doesn't know about them is because they're local variables down here in main. So what main has to do is it has to pass them into average so that average can then know about them. So we'll pass them in as three separate parameters, num1, num2 and num3. Now if we're passing in 3, then average has to be rewritten in such a way that it will actually accept 3. All three of them are integers, so we'll write it like this: int n1, comma, int n2, comma, int n3. Notice that I have not called them the same names as the ones down here. I could have called them the same names. I could have called them num1, num2 and num3 instead of n1, n2 and n3, but I chose not to make it easier to see what's going on. Now I'm not quite done, because I still have to rename these a little, get rid of the UMs in there. So now that refers to n1 plus n2 plus n3. So that's pretty much all the chopping and changing that I'm going to do. We've now created a separate function that contains all of the calculations that we're going to do in this program. Ultimately the goal would be to have another function for the input, another function for the output, which is kind of what we had before in the first average example, but no global variables, and we'll have a look at that in the next module. In the meantime, let's compile this and see if it works. It runs, and we'll enter, say, 4, 5 and 6, and the average is 5. So it is not only compiling and running, it is actually working. Now before we move on to the next module, there is actually quite a big limitation associated with function parameters in C. To find out what that limitation is, we're going to have to open up double.c.
Okay, here's double.c. Very simple program. Enter a number and then call a function called double_it. I couldn't just call the function double because that's a keyword, a C keyword. Obviously means a very long float, so we don't want one of those. So we'll call it double_it. Okay, and double_it is up here, and you pass it its parameter n1. We'll call it num1 in here, but when it's received up here it's n1. Notice it could also be called num1 here, but I don't wish to do that. And all the program does is it multiplies n1 by 2. Okay, so pretty straightforward. Let's check it out. Oh, we print out the value, of course, of the doubled value. Let's check that, see if that works. Compiles, runs, please enter the number, about 4. Oh, doubled value, forgot the word is, but the doubled value is 4. Something's wrong. Something is wrong. What is our little function, our little double_it function appears to be not working. which is odd because it looks straightforward enough. Just take the number and multiply it by 2, put the number back into n1. We could have just done it like this. n1 times equals 2, that would have worked. That's how you double a number, the simplest way. So I'll leave it like that. But whether we do it the simple way or the slightly longer way, it's still not working. And anybody think why? Okay, I wouldn't expect you to know the answer to this. The answer is this. When you pass a parameter from here to here, you're actually passing, well, what actually happens is this variable gets created. It is a duplicate of this variable. It's a copy. It's a copy in the exact sense of the word. It's a complete copy. Here you have one integer and here you have a second integer. And this second integer is it's local only to the function called doublet. It's a new local variable. And as soon as the doublet function disappears, it takes n1 with it. So the whole thing disappears, n1 as well. So, can you see where I'm going with this? It is the copy that gets doubled. The original does not get doubled. The original is over here. We've got one variable called num1, and then we've got a copy of that called n1, and n1 gets doubled, but num1, nothing ever happens to num1. So, to sum up exactly what's happening, when you pass a parameter to a function, it's almost like there's a hidden line in the program that does this. n1 equals num1. Almost. I mean, that does happen, but it doesn't happen visibly. You don't see it happening. But that's exactly what happens. n1 gets the value of num1 somewhere off in limbo land before the doublet program, the doublet function actually starts. But nowhere is there ever a line after the function ends that says num1 equals the value of whatever n1 happened to be when the function finished. That does not happen. No, no, no. It's a one-way street. The copy only happens in one direction. It happens as you're calling the function. It does not happen again in the other direction when you end the function. Which is, well, it's not necessarily a problem. It's just a limitation of C. And in a later chapter, when we get up to pointers, I'll show you how to get around that limitation. It's a somewhat messy and complicated way of getting around it, but every C programmer learns it, called pointers, and we'll learn it too. If you're a programmer, if you've already programmed in other languages, this method of passing parameters from one function to another is pass by value. C only ever does pass by value parameters. It never does pass by reference. C++ does pass by reference, but you have to call the reference explicitly. Anyway, if you don't know what that means, it doesn't matter. Needless to say is that line never happens. This line does happen, but it doesn't happen explicitly. It only happens implicitly. So what's the immediate solution? Well, there is no immediate solution. There's no solution that doesn't involve something we haven't already learnt yet. So in the next module, I'm about to show you, I'll show you a solution to this particular problem. I'll show you a way of getting around this problem. Okay, that's called returning a value from the function.